Welcome to Lesson 8 of the Introduction to Python course. In this lesson, we will discuss exception handling. One of the most common things that you will encounter while programming are bugs. These are exceptions or errors that occur due to various reasons, like improper syntax, incorrect spellings, and so on. In this lesson, we will see how to anticipate potential errors and how to handle them in the right way. Let's start with exception basics. In school, we've learned that it's not possible to divide by zero. So for example, let's say we have a single pizza. It can either be shared by multiple people or eaten by a single individual. However, it cannot be consumed by 0 people. It's just not logically possible. In the same way, if we try to divide any number by 0, we will get an error. In Python, we get the zero division error. So let's just see how that looks. Let's say we do 1 divided by 0. As you can see, we have run into the zero division error. It says division by 0. So basically, it's giving us the information about what the error is and why it happened. Now, in some situations, it might be okay to allow the Python interpreter to observe and report these errors as and when it identifies them. But there are times when we would prefer to expect and handle these errors in some particular way. We can do this with the help of the try and except blocks. For example, we have try, colon, 1 divided by 0. Then we say except, colon, print, you cannot divide by 0. Sorry. And when we run this, you can see that we get a much more aesthetically pleasing error. In the previous case, Python just threw the error at us and it looks very messy here. But in this case, we get an error that we have defined on our own. Now, we can have multiple except clauses within our program. Each of these clauses would specify the type of exception that needs to be caught by the interpreter. So let's see this in an example. Let's say we have some function called divide. Then we say try. So basically over here, we are opening up the try block. Then we have numerator equal to integer input enter a numerator. So we are accepting some input from the user, converting it into an integer and saving it within the variable numerator. Next we have denominator. Same as before, integer input enter a denominator. Then we have result equal to numerator divided by denominator. Then we have print numerator, comma, over, comma, denominator, comma, equals, comma, result. Now we have except value error, and we print integers only, please. Try again. Oh, right. And after that, we say divide. Next, we say except zero division error, we print you cannot divide by 0, try again. Divide. Then we say except we have to name this here. So this becomes except keyboard interrupt print you have quit the program. And then we have except and then print I don't know what went wrong. So that's it. So that's the end of our try block. Now we define our main function. We call divide. And then we call the main function. Okay, right. So there's an error over here because I have put this colon outside the quotation marks instead of inside. Now, I'm prompted to enter a numerator. So let's say I enter, let's say I do 1, and the denominator is 0. So it says I cannot divide by 0, and it allows me to try again. Now, let's say I put 5 and 0. Once again, gives me the 0 division error. Now, let's say I randomly type in Jill. It says integers only, please, try again. Let's say I put a number here and then I say Jack. It'll give me the value error as well, and it says integers only, please, try again. Let's now move on to an exercise to understand how to raise various types of exceptions. In this exercise, we will intentionally try to create different types of exceptions with the help of the following template. So we have our given code over here, we have try, then we need to enter some code here that would create an exception, and then we would have this. So there are a couple of different errors that we can try. So we need to use try and except blocks to raise these errors. Let's see how to do this. So let's start with the 0 division error. Now we will say try 1 by 0. Then we have except exception as E. Then we have print type E. And then we have print E. And since we have a couple more lines of code after this, a couple more things to be printed out, let's just add a line here. There we go. So this is the code for the 0 division error. Now let's say we want to print out a value error. So we have try integer a except exception as E print type of E and then print E comma new line. Then we have name error. So we have name error, try, print foo, foo, except, exception as e, print, type e, and then print e new line. Then we have the file not found error. We have try, open, non-existing file.txt, read, except, exception as e, print, type e, print e. Right, and we have the new line as well. Then we have import, error, we have try, import non-existing module, except, exception as e, print, type e, print e, new line. So next we have type error. Let's just go back and check. Yeah, so we have type attribute, stop iteration, key error. Okay, so we have type error, try, nums equal to 1, 2, next, nums, except, exception as e, print, type e, print e, comma, new line. Now we have attribute error. This will be try, greeting equal to hello, greeting dot print, except, exception is e, print type, no, sorry, print type e, print e, new line. Then we have stop iteration. This is our second last one. So we have try, nums 1, 2, iter underscore nums, iter nums, print next iter nums, print next iter nums. Once again, print next iter nums. Except exception as e, print type e, print e, new line. All right, and now we have our last one, which will be key error. We have try grades equal to English 97, math 93, art, let's give it 74, and music, which can be 86. Then we print grades science, as you can see, science is not there in the dictionary. Then we have except, exception as e, and once again print type e, print e, new line. All right, so let's run this entire thing. So now when we run this code, we get all the results as expected. So we get division by zero error, which is zero division error. We get value error, name error, file not found error, module not found error, type error, name error, and stop iteration and key error. That's it. So we have now seen how to raise exceptions in various kinds of scenarios. Now we will have a look at the else clause. Generally, we should limit our try clause solely to the code that could cause an exception. After the final except clause within the try code block, we can include an else clause. This would contain some code that would run only if no exception was raised within the try clause. So let's see this in an example. Let's say we define some divide function. We have try, we have numerator equal to integer input, enter a numerator. Now, if you remember, we have actually done this code before. We have, our divide function. So let's just save time here and let's go back and let's copy and paste the same code. Here we are. So let's just copy this whole code. All right. So we will erase all of this and paste over it. So we have the same code over here. Now, the only thing that we are going to be modifying is this. After this except clause, we will add another line of code, and we will say else, followed by print. Numerator over denominator equals result. That's basically what we had over here, right? And what we're going to do over here is remove this. Now let's see what happens when we run this. So we have enter numerator, let's give 4, denominator 0. It tells us we cannot divide by 0 and that we should try again. Now let's say we put in something that's correct. So we'll do 60 and 45. So we'll get 60 over 45 equals 1.3 and so on. So we have included the final print function call within the else clause because we can be certain that it will not raise any kind of error. Now we have the finally clause. The finally clause is used mainly to clean up code. So for example, we may need to close some connections, release resources, and so on. Usually, we use this clause only within a nested try except block. So here's an example of the syntax that can be followed when using this code. So we have try, we have resource, resource. So this would be some kind of generic resource, and then we have resource.open, which would open resource. So basically, if the resource fails to open, then the execution of the code will jump to the outer except block, and it will skip the whole try block that we will be writing in the next few lines of code. So we have try, and we will, over here, we will just do something with the resource. It can be anything. As I said, this is just a syntax. This is not an actual piece of code. So we will say resource dot do something. Then we have except. We will re-raise the error to the outer block. And raise, else we will do something safe. Finally, we will close the resource. This will basically happen even if an exception occurred in the inner except block that we just had above. So we will say resource dot close, and then we will say except exception as E. So the resource failed to open, so we don't really need to close it. And then we will just print something bad happened. And then we will print E. Next we will say else. and then we will just randomly add do more stuff here. So this can be anything. So basically what we see in this code is that the resource should only be closed and always be closed if it was opened successfully, regardless of whether or not some kind of error was thrown after it was opened. But if the resource does not open successfully, then we should not try to close it. For this reason, resource.close cannot go in any kind of hypothetical finally block in the outer try. Now don't worry too much about this because this is mainly an advanced situation, and in general we rarely have to use the finally block for exception handling. Now let's see how to use exceptions for flow control. For example, instead of evaluating some given condition before proceeding with the rest of the code, the program can go ahead and try to proceed with the code and then respond as required when an error is brought up. We will see this in the following examples. So let's say we have two different codes. So we have square num and we have cube num. Now compare the square num function, which uses exception handling, with the cube num function, which uses an if condition to accomplish pretty much the same thing. So let's write the code first. So we have square num. We have try num equal to integer input integer. Then we have except value error, and we print, sorry, there's an indentation mistake here. This should go there. Print comes there. So we print that is not an integer. Else and let's just add a period here. Okay. Else we print num squared is num to the power of 2. So that's it for our square num function. Now we will define our cube num function. We have num equal to input number if num dot is digit we print num cubed is integer num to the power of 3, else we print that is not an integer. All right, so in this case, first we have a square num function that uses exception handling, and second, we have the cube num function that uses an if condition. So this is how we can accomplish pretty much the same thing, but in two different ways. So let's jump into an exercise to understand this method of flow control a little better. So in this exercise, we will take a function that uses the if-else method of flow control, and we will modify it to work with the try-except method instead. We will first observe the given code in which we find that the program repeatedly prompts the user to input a number. as you can see here. Each valid entry is added to a total. If the user types in Q, the program quits. If they enter any other value that is not an integer, the program prompts them for an integer value. Next, we will replace the if-else code block with the try-except code block to obtain the same result. And this is basically how the output should look. So this is just a sample output over here. So let's go ahead and try our solution. So we will define our function as the main function. Then we have total equal to 0. And then while true, try num equal to input, enter a number, or Q to quit. If num dot lower is equal to Q, we print, sorry, I forgot colon there. We print goodbye and break. Then we have num equal to integer num. Then we have except value error, print integers only, please. Try again. Else total plus equal to num, and then we print the current total is total. So that's about it. Now when we call our main function, this should work in the same way as the given code over here, which used if else. So let's try this and see what happens. Okay, so we've already run into an error. That is because I have missed out something here. So let's debug this program. Right, now when you look at this program, you can easily see what went wrong here. Basically, what happened was the indentation. This needs to come at the same level as try. Likewise, else needs to come at the same level as try. And this accordingly needs to be edited. There we go. Now this should produce the output that we need. As you can see, it does. So let's enter a number or Q to quit. So let's start with some number. Let's go with 7. The current total is 7. Now let's try 7 again. That becomes 14. Now we'll go with 14. We get 28. Now let's go with 2. We get 30. And if we go with 90, we get 120. And if we go with 10,000, we get 10,120. And let's say we just type in a word like kitten. It says integers only, please. Try again, and gives us the current total. Now let's give one last number. Let's give 0.73. It says integers only, please, because it doesn't even accept float values. So once again, let's give a 1. The current total is 10,121. And now if we say Q, it exits the program. Pretty interesting how that works, right? So let's take a look at how we can make our own exceptions. In some situations, it helps to be able to raise our own exceptions. This can be done with the help of the raise statement. Let's look at an example here. So we have, we define a function by dict d. d2 is equal to d dot copy for k comma v in d dot items d2 square bracket v is equal to k, and then we return d2. So here we create a bidirectional dictionary from a dictionary. So if we pass something like holla, hi, adios, bye to this function, it will return this dictionary. Holla, hi, adios, bye, hi, holla, bye, adios. Now we can use this new dictionary to look up values in either direction. But if we pass by dict, a dictionary that has two keys with the same values, something like this, where we have holla, hi, adios, bye, and ciao, bye. We won't get an error, but we also won't get the mapping that we want, because the bye key can only have a single value. So we get holla, hi, adios, bye, ciao, bye, hi, holla, and bye, adios. The value of the bye key is adios, but there is no key with the value of ciao. Now consider the loop in the bidict function. It assigns a value to a key each time unless that key already exists, in which case it overwrites the existing value. So one way to handle this is to raise an exception, something like this. So we have def bidict d d2 is equal to d dot copy for k comma v in d dot items if we in d2 dot keys we raise a key error cannot create bidirectional dict plus with duplicate keys. Then we have d2 v equal to k, and we return d2. So now when a programmer tries to pass a dict that won't work with the function, it will raise an exception. So the full code would look something like this. We would define bidict d. We have d2 equal to d dot copy. And for k comma v in d dot items, if we in d2 dot keys we raise key error, which is the same thing that we have over here. So let me just copy and paste this. Then we have d2 v equal a k, and we say return d2. I just noticed here there was a little mistake. This should be, there we go. We really have to keep an eye on the indentations because each indentation can make such a difference to the program. Now we have translator equal to by dict holla hi adios bye. Then we print translator holla then we print translator hi, and then we have translator 2 equal to by dict holla hi adios bye and ciao bye. Now when we run this, we get hi, we get holla, and then we get the key error. So the call creating translator works, but the call creating translator 2 does not work. It says cannot create bidirectional dict with duplicate keys, which is what we mentioned over here. So this is basically how we can raise our own exceptions within a Python program. So that's about it. In this lesson, we have learned how to handle Python exceptions and how to anticipate them as well. So for further study, you can have a look at this link over here. It's the official documentation for Python.